taste and some are bitter. So the sweet taste is because due to the presence of the sugar in it, and the sour taste is something like the curd, the vinegar, the tamarind, the lemon juice, and all. We can able to find the sour taste, and the others are sweet, and the bitter is nothing but that. Um, the soaps are bitter in taste. Suppose if you are taking bath, that soap is going inside our mouth, so we feel so kind of the bittery one. And so these are all the different types of taste we are uh, know. So in that one, the sour taste. So usually we will have the lemon juice, the tamarind. We'll add it in our food. So in that one, we can able to taste the sour taste. So the acid is nothing but it's come from the Latin word the acidus. It's meaning sour. So the anything that tastes sour that contains the acid. So for example, lemon juice, tomato, vinegar, etc. So all will taste sour. So some of the substances must contain the acid, and so some of the common examples are orange, lemon. So this contains the orange lemon contains citric acid and the ascorbic acid, that is vitamin C, and apple is malic acid, tamarind, imli, that and the grapes it contains the tartaric acid, vinegar contains the acetic acid, curd contains the lactic acid, tomato contains the oxalic acid, gastric juice, so which is present in our body, the gastric juice which contains the hydrochloric acid HCl, tea contains the tannic acid, red ant contain the formic acid. So all acids are generally sour in taste. Okay, so how can we able to find out the acid? So we can use the litmus paper. The litmus is nothing but it's just a pigment which we will get it from the plant. So that if you keep, there are two litmus papers are there. One is the red litmus, another one is the blue litmus. So if you use the blue litmus, so it turns the red, which indicates that the presence of an acid. And also, the acids can able to conduct the electricity because it can able to dissociate into the H plus and the other anion. So it can able to conduct the electricity, and it can also combine with the bases and form the salts under the water. That is nothing but the neutralization reaction. Acids reacts with bases to forms the salt under the water. And so the acid we can able to define by so many ways. So an acid is a compound which contains the hydrogen. Say for example, I take any acids, HCl, sulfuric acid, nitric acid, any acid. So all contains the hydrogen. So H plus in it. So that we call it as a acid. So whether that depends upon the strength of the acid, whether it can give completely or partially. So some acids give complete H plus ions. Some acids can able to give only partially. So and depends upon the reactions also, it will vary. So for example, the H2SO4, that is the sulfuric acid. So this we call it as acid because it contains the hydrogen atom in the molecule. And also there are H2. It indicates that there are two hydrogen atoms present in the molecule. So it can be easily replaced or partially by the metal like a sodium. So why are we using particularly the sodium here? Because the sodium is a high reactive metal. So it can able to replace the H plus from the sulfuric acid. So in the place of the hydrogen, we are substituting the one sodium atom. So that we call it as sodium, then hydrogen sulfate. So H2SO4, the one sodium atom. So when you are adding the one Na plus, one H plus have to remove it. So NaHSO4. So sodium hydrogen sulfate. This we call it as a partial replacement. Then if you are giving adding the two Na plus, so the two hydrogens are replaced by the two sodium ions. So Na2SO4. So this is sodium sulfate. So this is a complete replacement. So the hydrogen ions in the H2SO4, it can be partially or completely replaced by the group of elements such as the ammonium ion. So NH4 plus. So this we call it as a ammonium ion. So it forms the compound NH4HSO4. So ammonium hydrogen sulfate. Suppose the other hydrogen is also replaced by the NH4 plus, means we got it NH4 twice. So the whole 2 indicates that, so this is the compound ion. So this plus is having NH4 equal to plus 1 charge. So if you want to write the 2, we should not write it for the hydrogen. We have to place the whole bracket, then we have to write NH4 twice SO4. So this is ammonium sulfate respectively. So here is the equation H2SO4. So now we are replacing one hydrogen, one H plus with the one ammonium ion. So it forms NH4HSO4. This we call it as partial replacement ammonium hydrogen sulfate. Now we are replacing the two hydrogen atoms with two ammonium ions. So NH4 twice SO4. So ammonium sulfate. This we call it as a complete replacement. Now, the substances such as sodium hydrogen sulfate, ammonium hydrogen sulfate, and ammonium sulfate, we call it as a salt. Okay, so the acid is dissolved in the water to make a solution that turns the blue litmus the red. Okay, so this is the property of the acid. So we can able to find out easily. Suppose in a beaker, we are having a different solutions. If you want to find out which one is this, so we can use the litmus papers to find out that. It is sour in taste. Yes, we have already tasted the lemon, tamarind, and also sour in taste. It reacts vigorously with your base to produce the salt. So this we call it as a neutralization reaction. Okay. So the hydrogen atoms present in the acid that can be replaced by the metal or the group of the elements are called the replaceable hydrogen atom. So in the H2SO4, we are having the two hydrogen atoms. At the same time, if you take the HCl that contains the only one hydrogen, so it can only one replaceable hydrogen atom is there. Suppose the phosphoric acid H3PO4, so it has the three replaceable hydrogen atoms. So next one is the classification of the acids. So depending upon the elements present in that, so the acids can be classified as oxyacid and the hydracid. Okay, so oxyacid means, so it contains the two elements, hydrogen as well as the oxygen. So that we call it as a oxyacids. Example, nitric acid, sulfuric acid, the phosphoric acid. So because in these molecules, compounds, we are having the two elements, oxygen as well as the hydrogen. As well as the hydrogen, oxygen as well as. So this we call it as a oxyacids. Hydracids means it contains the hydrogen. Basically, it has to contain the hydrogen. Along with the hydrogen, it should contain other non-metallic elements except the oxygen, such as, for example, fluorine, chlorine, or some other elements, non-metals, that we call it as a hydracids. So again, the hydracids are divided into classified as follows: organic and the inorganic acids. Okay, so the organic acids are nothing but that derives from the nature that we are using in our day-to-day life, such as the citric acid and all. So that is the organic acids. So the inorganic acids are nothing but it contains the inorganic metal, such as the non-metal it contains, chlorine, then nitrogen, sulfur. So that is all it contains. That we call it as a inorganic acids. So inorganic acids are also called as the mineral acids. So HCl is also present in the gastric juice in our stomach. Next one is the concentrated and dilute acids. So concentrated in the sense, so there will be, suppose, what is meant by solution? So solvent plus solute, we call it as a solution. So concentrated means we have added the less amount of the water, that we call it as concentrated. Dilute means we have added the more amount of the water. So here also in the laboratories, we are preparing the acids to find out the concentration of the bases or some other compounds. So in this case, the acid solution may be a concentrated or dilute depending upon the amount of the acid which is present in the solution. So generally we are using these things in the laboratories. So all the acids are generally it's soluble in the water because it can able to form the plus minus charge, so they are the polar one. So polar molecules can able to dissolve in the polar water molecules. So when the solution contains the large amount of the acid, so that we call it as a concentrated. So the solution contains the smaller amount of the acid, so which has a large amount of the water in turn, that we call it as a dilute solution. So the concentrated and dilute solution of an acid differ from each other only in the proportion of the acid, that is the ratio between the water and the acid. Strong and weak acid. Okay. So this one is based on that whether the acid can able to give the complete H plus when they are dissolved in the water, that we call it as a strong acid. So the weak acids are the one it can able to give partially the H plus ions when they are dissolved in the water. So the strength of the acid can be determined by the amount of the hydrogen ions provided by the acid when they are dissolved in the water. For example, HCl, HNO3, H2SO4, these are all we call it as a very strong acid. Suppose if we are taking the 100 molecules of the HCl, so when you are dissolved in the water, we will get the 100 molecules, 100 H plus ions as well as the 100 Cl minus ions. So this we call it as a strong acid. So weak acid means, suppose if we are taking the 100 molecules of the acid, so only the 10 molecules of the acid dissociated into the H plus. So that we call it as a weak. Remaining 90 percentage exist as the acid. Okay. So for example, for the weak acids, H2CO3, we call it as a carbonic acid, and the acetic acid CH3COOH. So these are all we call it as a weak acids that can able to give only the partial H plus ions when they are dissolved in the water. Okay. Next one is the basicity of an acid. Basicity in the sense, so if you're taking one hydrogen, one acid, how much replaceable hydrogen atoms that particular acid can able to provide. So that we call it as a basicity of the acid. Suppose if the acid is contains only one replaceable hydrogen atom, that we call it as a monobasic acid. And the basicity is 1. Suppose the acid contains 2 or 3 replaceable hydrogen atoms, that we call it as a dibasic or tribasic acids, and their basicities are 2 or 3. So example HCl. So HCl contains only one hydrogen atom, so it contains only one replaceable H plus ions. So the basicity is 1. HNO3, nitric acid. So in the nitric acid, it also has only one hydrogen, one H plus replaceable hydrogen atoms. So thus we call basicity is 1. H2SO4, sulfuric acid. So H2, so there are two H plus ions are present. So the basicity of the acid is 2. H3PO4. So there are three replaceable hydrogen atoms are there. So we call it as a basicity 3, tribasic acid. So now next one is the preparation of the acid. So how can we able to prepare the acids? Synthetic method. So the acids can be prepared by the direct combination of the elements. So for example, so now if you want to prepare the HCl, so we have to take so there are two atoms are present in the HCl. One is the hydrogen and the other one is the chlorine. So hydrogen gas we have to react with the chlorine gas together in the under the action of the electric spark. So it will produce as the HCl gas. So once it produced in the form of the gas, so what we have to do is we have to So once the gas is coming outside from the reaction, so immediately we have to dissolve in the water and it will produce as the hydrochloric acid. Similarly, so the sulfuric acid may also obtained from the following elements. So the sulfuric acid preparation is sulfur plus oxygen gives the sulfur dioxide. So the sulfur, so from where we are getting the sulfur is, it's from the fossil fuels. It's present as the impurities which is associated with the fossil fuels. So we can remove the sulfur content from that one and we have to burn in the presence of the oxygen. So we will get the sulfur dioxide. Then the sulfur dioxide, again we are reaction with the O2 oxygen, we'll get the sulfur trioxide. Then the sulfur trioxide have to react with the water, we will get the sulfuric acid. Then the next method is dissolving acidic oxides in the water. So acidic oxides in the sense, non-metallic oxides or generally we call it as a acidic oxides because when the non-metallic oxides dissolves in the water, we will get the um, acid. So that's why the non-metallic oxides are acidic oxides. Say for example, SO3. S is the non-metal which combines with the oxygen. So this is the non-metallic oxide. So when we are dissolving in the water, so we will get the H2SO4. This is nothing but the sulfuric acid. Then similarly, the carbon dioxide, the CO2. So carbon is the non-metal which combines with the oxygen. So carbon dioxide, when dissolves in the water, it produces the carbonic acid H2CO3. Then by the action of the acid on the salt of the another acid. Say for example, so now I would like to prepare the HCl. So I am taking the one acid H2SO4. So, and the salt of the which I would like to prepare. Say, for example, I would like to prepare the HCl. So, I have to take the Cl in common and I have to take one metal in that. So, the salt we have to take it. So, one of the hydrogen from the acid, because you know that acid is the one which is a proton donor. Proton is nothing but the H plus. So the H plus from the sulfuric acid is moved towards over here. So the Na will go and join over here. So sodium hydrogen sulfate plus HCl. So this is the another method to prepare the acid. General properties of the acids. They are sour in taste. They turn blue litmus paper red and also they show the acidic properties. Yeah, so the acids always shows when they are dissolving in the water. And so how can we do that one is, so what will happen, the dry hydrogen chloride gas does not produce the H plus ions in the absence of the moisture. So it produces the H plus ions only in the presence of the moisture. So HCl, when we are combining it with the H2O, so it will give the, so one of the hydrogen, it will move on to the H2O and it forms the H3O plus Cl minus. So their aqueous solutions can conduct the electricity. So aqueous solutions means the acid which is dissolved in the water. So that we call it as a aqueous solutions. So it can able to conduct electricity. So because of the presence of the ions H plus and Cl minus. So because of the presence of the positive and the negative ions, so the acids can able to conduct the electricity and they can react with the certain metals and with evolution of the hydrogen gas. Yes, so usually it will react with the high reactive metals such as the sodium, potassium, magnesium, calcium, aluminum. So when the metals reacts with that acid, immediately it will produce as the hydrogen gas, which we can confirm from the bubbles which can able to see in the reaction. And how to confirm the hydrogen gases, when we keep the wooden splint so in the gas, so you'll get the pop sound, so it indicates that the presence of the hydrogen gas. Okay, so now the examples, so such as the potassium, sodium, calcium, magnesium, aluminum, zinc. So it can able to react with the aqueous solution of the acid to avoid the hydrogen gas. So now the sodium metal is reacts with the HCl. So what is happening? H2 gas is liberated. So we'll get the salt NaCl. Then Fe is the iron metal. So when we are using the HCl, so FeCl2 plus the hydrogen gas is produced. Magnesium reacts with the H2SO4 and it produces MgSO4 plus H2 gas. Okay, so why in this reaction we have used the two, but in this reaction we have used the only 1 mole of the metal, because the sodium is present in the group 1 and it can able to form the +1 charge. So that's why. But in this case, we here the iron is a +2 charge. And magnesium is also from the group 2, it's a +2 charge. So that's why we are not writing the 2 in front of the Fe and the Mg. Now, aluminium 2Al plus 3H2SO4 gives Al2SO4 thrice plus 3H2 gas. Here, the aluminium is from the group 13, so it can able to form the 3 electrons it can lose. So, it can able to produce the 3 moles of the hydrogen gas from the sulfuric acid. So this reaction shows certain metals can displace the hydrogen atoms from the acids to form the salts. Now, next one is the nitric acid. With the nitric acid, when we are adding to the metal, so we will be getting the hydrogen gas. Mn is the manganese. Manganese reacts with nitric acid and it produces the manganese nitrate plus hydrogen. Okay. Nitric acid does not behave like this with any other metal. They can react, acids can able to react with the base to produces the salt and the water, that we call it as a neutralization reaction. And also the acids can able to react with the carbonates and the hydrogen carbonates to form the carbon dioxide and the salt. So sodium carbonate, the formula is Na2CO3. So which can able to react with the HCl. So it forms the NaCl plus water plus the carbon dioxide gases released. Sodium carbonate can able to react with the sulfuric acid. It forms the sodium sulfate plus water plus CO2. Then the calcium carbonate can able to react with the HCl. So it gives calcium chloride CaCl2 plus H2O plus CO2 gas. Okay, how will you confirm that the carbon dioxide is coming outside? So we have to use the lime water, which is nothing but the slaked lime CaOH twice. So when we are passing the carbon dioxide gas into the tube of the slaked lime, so the white precipitate we will get it. It turns milky in the sense the white suspension of the liquid we will get it. So this indicates that the presence of the carbon dioxide gas. Then NaHCO3. This is sodium hydrogen carbonate. Only one hydrogen only we have replaced it with the sodium. When it reacts with the HCl, we'll get NaCl plus water plus CO2. Then NaHCO3 reacts with the H2SO4. We will get Na2SO4 plus water plus carbon dioxide gas. So now the fire extinguisher. So what is a fire extinguisher? So the reaction between the sulfuric acid and with the sodium carbonate or the sodium hydrogen carbonate, it is used in making the fire extinguisher. So because the carbon dioxide gas is given out from these reactions. So this carbon dioxide can able to extinguish the fire. So a sealed glass tube filled with the dilute sulfuric acid is kept in the container. So this is the container. So we have kept the in this one a small container we have placed it, which is filled with the H2SO4. So this contains the sodium carbonate solution. Okay. So now once this plunger is on, so what will happen? The reaction between the H2SO4 and the sodium carbonate, the reaction will takes place. So immediately, so from this nozzle, we will be getting a lot of carbon dioxide gas. So which if the gases comes out from the nozzle, so if we direct it towards the fire, so it will extinguish us. So this reaction is very good, important in all the, suppose in the laboratory and all, it may catches the fire. So we have to use the fire extinguisher. So we can use this reaction in that one. Next one. The acids reacts with the oxides of the metals to form the salts and the water. So this is the Na2O, sodium oxide. So the metallic oxide. So the metallic oxide always is a basic oxide because when you are dissolving in the water, we will be getting the NaOH. So which is nothing but the base. So that Na2O reacts with the HCl. Actually, this is the base and the acid reaction. So we'll get the NaCl plus H2O. So this is the neutralization reaction because the acid reacts with the bases. Again, the copper oxide, copper is the metal. So it is a metallic oxide and it's a basic one which reacts with the sulfuric acid and it produces the copper sulfate, the salt plus H2O water. Calcium oxide reacts with the HCl. It produces the calcium chloride plus water. Okay. All acids contains the hydrogen. All acids are having this chemical, having a similar chemical properties. It can able to react with the Na2CO3, NaHCO3, and it can able to react with all the bases. Everything, the chemical properties and all the same. But the way of reaction will be the different. The rate of the reaction. One will be reacting very fast, one will be reacting very slow. That depends upon the strength of the acid. Either it may be a strong acid or the weak acid. So all the acids must have something in common. So we know that when all the acids reacts with the metal, it produces the hydrogen gas. So it means that the hydrogen is the common substance, so which is present in all the acids. But all the compounds containing hydrogens are not acids. So how can we come to know that whether it is acid or not? So when we are dissolving in the water, so it should capable of produces the H plus ions. Then we call it as an acid. Say for example, the alcohol. Alcohol contains the OH group and also the glucose C6H12O6. So the glucose also contains the hydrogen atoms, but they are not acid because when you are dissolving in the water, they cannot able to produce the H plus ions in the solution. And also we can able to test using the litmus paper, blue litmus. So it will not turn the blue litmus to the red. Then comes to the uses of the acids. Okay, so some of the uses of the organic and the inorganic acids. So the organic acids first. So the organic acids are nothing but which we are getting it from the nature. So the citric acid. So citric acid is used as a preservative for the food and also the flavoring agent. Ascorbic acid is also called the vitamin C in the treatment of the bone marrow and the scurvy diseases. Next one is the acetic acid. So added to the pickles to make them sour. Tartaric acid, the component of the baking powder. So the baking powder is nothing but that mixture of the sodium hydrogen carbonate and the tartaric acid. Inorganic acids, the first one is the HCl. So it is present in the gastric juice. So that will help the digestion of the food, whatever we are eating. And also it's used as a bathroom cleaner. And also one of the important uses nothing but the manufacture of the polyvinyl chloride, PVC. Nitric acid. The nitric acid present in the rainwater, it forms the nitrate in the soil, so which can be used by the plants for the nitrogen fixation. And also it is used in the manufacture of the fertilizers like the like ammonium nitrate, NH4NO3, and also used to make the explosives such as the TNT, trinitrotoluene, and also the dynamite. Sulfuric acid, it is used in the storage batteries. So in the manufacture of the fertilizers, paints, and the pigments, detergents, and artificial fiber. And also in the manufacture of the hydrochloric acid and alum. Phosphoric acid, so it is used in the fertilizer and also in the detergent industries. Boric acid in the manufacture of the glass, glazes, and the enamels. Adhesives and the explosives, and also it is widely used in the detergents, and also it is used as a grain preservative. Okay, so that's all about the acids. Then we are going to see about the bases. So what is meant by a base? A base is just opposite to that of the acid. So it is bitter in taste. It's a soapy feel to touch. So a base is a substance, usually it's the oxide or the hydroxide of the metal. So for example, Na, if you're taking the Na, so it will be either Na2O or the NaOH. So which can react with the acid to produce the salt and the water. For example, Na2O, sodium oxide, calcium oxide, it's a CaO, and cupric oxide is CuO, and iron oxides, FeO and Fe2O3, sodium hydroxide, NaOH, calcium hydroxide, COH twice, or all bases. Certain substances are also called the bases, but it will not fit into the above definition. The one of the very good example is the ammonia. It's a weak base. So it does not contain any OH minus ions, and also it does not contain any metal. It's made up of only the non-metal NH3, nitrogen and the hydrogen. But it forms the salt with acid without giving the water. So it should not be treated as a base, but ammonium hydroxide, the aqueous solution of the NH3. So it reacts with the acid to give the salt and the water. So NH4OH. So the NH4OH is nothing but the ammonium hydroxide, which can able to react with the HCl. So this OH minus is taken by the hydrogen, so it forms the H2O and plus NH4Cl, ammonium chloride. Okay. So now again we are uh, splitting the bases. So in that one, the bases, all bases are not soluble. Some of them are soluble, some of them are insoluble. If it's soluble, we call it as an alkalis. Okay. So for example, sodium hydroxide, potassium hydroxide, calcium hydroxide, so which are easily soluble in the water. So those are all we call it as a alkalis. So but the bases like copper oxide, copper hydroxide, CuOH twice, ferric hydroxide, FeOH thrice, aluminum hydroxide, AlOH thrice, they do not dissolve in the water. So they are not alkalis. So we call it as the bases. So one of the important one is all alkalis are bases and all bases are not alkalis. So the basis is the main form and the alkalis is the subform of the base. So the one which can able to dissolve in the water, that we call it as a alkalis. The one which do not dissolve in the water, that we call it as a base, which is a common term. Examples here: oxides, sodium monoxide, Na2O. So soluble, when if it is soluble in the water, so we will be getting the sodium hydroxide actually. So insoluble hydroxide is FeOH thrice. So it is insoluble in the water. Calcium oxide, CaO, when it dissolves in the water, we will get calcium hydroxide, that is nothing but a slackered lime. Potassium hydroxide, it is easily soluble in water. And the aluminum hydroxide, which is nothing but the alum, AlOH thrice, it is insoluble in the water. Cupric oxide, CuO, so it forms the CuOH twice, and ZnO. ZnO is actually the amphoteric oxide, so which can easily produce, it can easily reacts with that and forms the ZnOH twice. Calcium hydroxide, ammonium hydroxides, which are all the examples of the soluble hydroxides. So lime water, baking soda, and washing soda are all bases. So now we are going to see the preparation of the bases. So, so the metal oxides. So the metal oxide means it contains the metal and the oxygen. So we have to precursor as the metal and as well as the oxygen. Suppose if you want to prepare the sodium oxide, so we have to treat the sodium metal with the oxygen. So Na plus O2 gives Na2O. And the potassium oxide K2O. So potassium plus oxygen gives K2O. And calcium oxide, so we have to react to the calcium plus oxygen and it produces the CaO. So these oxides, so okay, how can we prove that these oxides are bases? So whatever the oxide it is produces, that we have to dissolve in the water. So Na2O, when it dissolves in the water and it forms the NaOH. So the hydroxides of the metal. Then K2O, when it dissolves in the water, it forms the KOH. Calcium oxide, when it dissolves in the water, it produces the CaOH twice. So by the action of the water or the steam on some active metals like sodium and the potassium react with the cold water to form the hydroxides with the evolution of the hydrogen gas. So the sodium reacts with the highly reactive metals only we have to take it. Say example, sodium, potassium and all because it can able to react even with the cold water vigorously. So Na plus 2H2O gives NaOH plus hydrogen gas. The magnesium reacts with the steam. Okay. So the magnesium cannot able to react with the cold water. It can able to react only with the steam. So the steam is nothing but that it is a water vapor. H2O in the form of the gas. So when the magnesium reacts with the steam and it forms the magnesium oxide plus hydrogen. So then the magnesium oxide, when it is actually a insoluble one, so we cannot able to react it with the water. So the Fe reacts with the steam superheated. So when we are more heated, that water it produces the water vapor. So the iron reacts with the water and it forms the ferrosulfuric oxide plus hydrogen. Then by heating the carbonates, okay. So whenever we are heating the carbonates, we will be getting the carbon dioxide gas. Along with that, we will be getting the oxides of the metal. So calcium carbonate, this we call it as a thermal decomposition of the carbonates. So calcium carbonate, when we are heated, so the carbon dioxide gas will be coming outside. Along with that, we will be getting the metal oxide, CO. Similarly, when the zinc carbonate, if you are heating, we'll get the zinc oxide along with that the carbon dioxide gas. So the next one is by the action of an alkali on the salt solution. So for example, when we are when an aqueous solution of the sodium hydroxide is added to the aqueous solution of the magnesium sulfate, so we will be getting the magnesium hydroxide. This is the base plus Na2SO4. The magnesium hydroxide is the insoluble one. So that's why they have shown it in the downward arrow mark. So it is a precipitate. So general properties of the bases. Okay, so what are all the general properties? It's a soapy touch. So when if you are adding the water to the base, so it splits up into the ions and it will give you the OH minus ions. So NaOH when dissolves in the water, so we'll get Na plus plus OH minus. So the CaOH twice when dissolves in the water, we'll get Ca plus 2 OH minus. Magnesium hydroxide when dissolves in the water and it gives Mg plus 2 OH minus. So they always turn the red litmus paper blue. Yeah. So If you want to find out whether it is a base or not, so we have to use the red litmus paper. If it turns blue, then it is a base. So this is just opposite to that of the acid. So for the acids, we have to use the blue litmus that turns the red color. Okay, suppose, okay, so if you want to test whether it contains the base or not, we can take the soap solution, because the soap contains the NaOH, so which is a base. So if the soap solution, if you dip the red litmus paper, so it turns the blue color. It indicates that the soap contains the base. Then the bases can able to react with the acids to produces the salt and the water. So neutralization reaction. So NaOH is the base, reacts with the HCl, hydrochloric acid. It forms the salt, NaCl salt plus water molecules. So the KOH, when it reacts with the sulfuric acid, it forms the K2SO4, that is a potassium sulfate plus water. Then copper hydroxide, which reacts with the sulfuric acid and forms the copper sulfate plus water. So in these reactions, what's happening over here is the both acids and bases are neutralizing. So what it means neutralizing? So the H plus from the acid and OH minus from the base both reacts and it forms a water. This we call it as neutralization reactions. So the neutralization reactions may be defined as it's the reaction between the acid and the base which produces the salt and the water. Okay, so now we are going to give an explanation. So here HCl plus NaOH gives NaCl plus water. So when we are dissolving the HCl in the water, so it will split up into the H plus and the Cl minus ion. So the NaOH, when we are dissolving in the water, splits up into the Na plus plus OH minus ion. So the NaCl is the salt, so it splits up into the Na plus plus Cl minus. So the water is a liquid, so it will not dissociate. So we have to keep the H2O as such. So what are all the ions are common? Na plus, Na plus. So we have to cancel out. Cl minus we have to cancel out. So the left out will be the H plus plus OH minus, which produces the water. So during the neutralization of an acid with a base, or the vice versa, base with the acid, so basically H plus from the acid and the OH minus from the base, it combines and to produces the water molecules. Then next one is the oxides, which produces the acids in the aqueous solutions, are called the acidic oxides, which are usually the oxides of the non-metals. Yes, so we have to take the acidic oxide, that is nothing but the CO2. When it reacts with the base NaOH, so it produces the Na2CO3 plus water. Then calcium hydroxide, when it reacts with the CaO, it is a base and this is the acid. So it forms a calcium carbonate plus water. At the same time, so when we are heating the base with the ammonium salt, so it will give you the ammonia. This is the test for the ammonium ions. Suppose if you are testing in the inorganic salts and all, suppose if we may think that the NH4 plus cation is present, so we have to add the little bit of the NaOH and we have to heat it. So immediately the NH3 gas, that is the ammonia gas, will become outside. So how can we confirm that ammonia gas it's only produced in this reaction? Means we have to use the red litmus paper. So it will turn into the blue. So which indicates that the ammonia gas is coming outside. And also it can be able to characterized by its pungent smell. So next one is the bases react with the certain salts to produce as the another salt and the another base. So for example, ammonium hydroxide, when it reacts with the aluminium sulfate, so it produces the aluminium hydroxide and the aluminium sulfate salt. The next one is the strong bases and the weak bases. Again, the same thing as we have seen in the strong acid and the weak acid. So the strong bases are the one when you are dissolving in the water, it will give you the completely ionized. So 100 molecules of the NaOH if you are taking, so it should produces the 100 OH minus ions. So that we call it as a strong base. So how much ion OH minus ions it can able to provide. So some bases when it's dissolves in the water completely dissociated. Dissociated means it's completely breaking down and it gives the hydroxide ions. Some of the bases it can able to give the partially dissociated one, so that we call it as a weak basis. So example, magnesium hydroxide as well as the ammonium hydroxide, which we call it as a weak basis. They cannot able to produce, they cannot able to give the 100 percentage of the OH minus ion. Instead it can able to give only dissociate very less, say for example 10 percentage or the 20 percentage. Then acidity of a base. Acidity of the base is nothing but the base can how many number of the hydroxyl groups is present in the molecule of the base, that we call it as the acidity of the base. So in the NaOH, KOH and the NH4OH, it contains only one OH group, that is one hydroxyl group. So the acidity of all the bases is 1. But in the case of the calcium hydroxide and the barium hydroxide, there are two hydroxides are present. Two hydroxyl groups are present in the one molecule. So it can able to neutralize the 2H plus. So the acidity is 2. And the acidity of the FeOH3 and the AlOH3 is 3. So because it contains the 3 OH minus ions. So it can able to neutralize the 3H plus. So the base contains one hydroxyl group in a molecule is said to be the monoacidic base. If it contains the two hydroxyl group, we call it as a diacidic base. If it contains the three hydroxyl group, call it as a triacidic base. So the NaOH, monoacidic, CaOH twice, dibasic, diacidic, FeOH thrice, it's a triacidic basis. Some of the common bases and their uses: sodium hydroxide NaOH. So it is used in the manufacture of the soaps, textile, paper, and the medicine. And also it is used in the refining of the petroleum. Ammonium hydroxide. It is a very good reagent in the laboratory, and also it is used in making the fertilizers, rayon, plastics, and the dyes. So the calcium hydroxide. It is used in making the cement and the mortar, and also it is used in making the bleaching powder, in whitewashing, and it to remove the acidity of the soils. Okay, what is the acidity of the soils? How the soil becomes more acidic? So when the acid rain is coming from the atmosphere, it contains basically the HNO3 and as well as the H2SO4. So it will affect the growth of the plants. So to neutralize that, we will use the calcium hydroxide. Hello.